unit, we're basically going to do two things. First is called combining functions. We're going to do it graphically and algebraically today, and then we'll go into tomorrow what's called composition of functions. That's it. It's really just stemming from transformations, which took us into radical and rationals, which took us into polynomials. This is kind of finishing off. So what we're going to do is take graphs you've already seen, your polynomials, your radical rationals, all those graphs, and we're going to add them and subtract them and multiply them and divide them, and then see what happens. That's the point of today. So we'll do it first graphically, then we'll do it algebraically. So to find the sum, difference, product, quotient of two functions graphically, you must add, subtract, multiply, or divide the values of the y coordinates while leaving the x coordinates unchanged. So they've given us two functions, f of x and g of x. What kind of function is f of x? It's a parabola. How do you know? Bless you. Because the shape, right? Shaped like a U. What is g of x? Linear. How do you know? Because it's a line. And what the question is asking us to do is add them together. So we want to know graphically what happens when you add a line to a parabola. I do it with table of values. There's other ways to do it. I just find this is the easiest, so this is what I'm going to show you. Pick an x value, any x value you want. 1. Give me some more x values. Do we want them all to be on the positive side? Okay, first thing I'm going to do is go to the f of x function and get the y coordinates. So just make sure you're looking at the correctly labeled graph. So we're going to f of x. So go to 1. Tell me what's the y coordinate of f of x at 1. What's the y coordinate of f of x at 1? 1. What's the y coordinate of f of x at 2? 4. What's the y coordinate of f of x at 3? And if you're having trouble seeing this, you can grab a ruler just like we did before. Right? So put your ruler at x equal to 3. Look up where it's hitting f of x. Look to the side. Y coordinate is? It's a parabola. This should not be a surprise. 1 squared was? 1, and 2 squared is 4. This is very painful. 3 squared would be 9. Okay, go to -2. Go to f of x. Tell me what the y coordinate is. And the last value we chose, -1. Offer of 1. Okay, now we're going to do the same thing. So go to where x equals 1. Now we're going up to g of x. And again, if you're visual, the ruler might help. Okay, tell me what's the y coordinate of g of x where x equals 1. 3. Confirm. Confirm. Okay, go to 2. Offer of 5. 3. Confirm. Okay, -2. -3 with a bit of a question mark there. And then a -1. Now we're going to do exactly what the question said to do, which was add them. So we're going to take the y coordinates and add them. 1 plus 3. 4 plus 5. 9 plus 7. 4 plus -3. And 1 plus -1. Okay, so there was our combining of functions. We added them together. The reason I've highlighted the 2 outside columns is because that's the new coordinate you're graphing. So now we're going to put a point at 1 and 4. Next point is going to be at 2 and 9. Three and 16's off the graph. Negative 2 and 1. And negative 1 and 0. What do we do with the points? Connect them. Now you just need to be careful is what kind of shape is this going to make? So when you add a parabola and a line, what do you get? It's a parabola. And then we're just going to label it. So f plus g of x. Why does a parabola plus a line make a parabola? Okay, so go back to what you know about polynomials from last unit. What's the degree of the parabola? Degree of the parabola is 2. What's the degree of the line? So what's the highest degree in there? 2. Are we going to end up changing that degree? Is there any way to make it bigger if we're adding? No, so the degree is still going to be 2, which means the answer still has to be a parabola. Think ahead, what's going to happen when we start multiplying? So if we multiply a parabola by a line, it's going to end up being a cubic, because that's when we change the degree is when we multiply and divide. If we're adding and subtracting, it's not going to end up changing the degree. Questions so far? Yep, it's this easy. Given the graphs of f of x and g of x below, find h of x if it equals f minus g of x and plot it on the same grid. Okay, what kind of graph is f of x? It's a linear function. What is g of x? High five, that's our absolute value. So base graph way back from unit 3. Okay, how do you recognize an absolute value graph? It's the v. Okay, so the v is the absolute value. Pick some values. Let's go from left to right this time, just makes me happier. So pick something on the left. Negative 4, pick another one on the left. Negative 2, we typically like to pick 0. Pick something on the right. And another point on the right. That was very symmetric, I enjoyed that. Now if you like the ruler trick, what you can actually do is both of these at the same time. So if I put my ruler at x equal to negative 4, go down to f of x, get the y value. Negative 9, I heard. Confirm. Okay, and at the same time, now go up to g of x. So when you put the ruler, you can actually do both at once. The y coordinate g of x. Offer of 4. Confirmation. Nobody confirming anything. Just make sure you're doing them in the right order because we're about to do a subtraction and it's going to matter. So make sure you're doing your f of x before your g of x. Okay, same thing at negative 2. So what's the y value of f of x at negative 2? Offer of 7. Offer of negative 7. I am not continuing without audience participation because I'm not doing this for me. Okay, go up to g of x. What's the y value at g of x? Go over to 0. Offer of negative 5. G of x. Okay, slide over to 2. And g of x. And negative 4. And that sounded like confirmed at the same time. Remember, you don't have to pick these x values. We just chose them randomly. You could use different x values. Okay, now just be aware of what the question is asking. So we're going to do f minus g of x. So that means we're subtracting the values this time, not adding them. So negative 4, or negative 9, negative 4. I heard like 5 answers at once. Negative 9, negative 4. Negative 7, negative 2. Negative 5 minus 0. Negative 3 minus 2. Minus 1 minus 4. Ooh, that's interesting. Take a look at what's happening here. Okay, we'll talk about why after we graph it. Out of this table, what are the actual values now we're graphing? So where do we get the coordinates? The first and the last one. So our x values will remain the same. It's our new y values. Okay, so negative 4, 13 off the graph. Negative 2, negative 9. 0, negative 5. 2, negative 5. And 4, negative 5. So what shape is this going to look like? Okay, so is it a swoop like our square root? Can't be a swoop because if this is all straight lines, this isn't suddenly going to be curvy. So what do you think it's going to look like? Sorry? Kind of, if you make it an angle. These need to be straight. This needs to be straight. So there's our very funky subtraction. Let's talk about why do we get this horizontal piece here? So we didn't calculate it, but what do you think is going to happen if we take the values at 6 and subtract them? And if we took it at 8? And if we kept going all the way to infinity, what's this always going to be? Why? Because these are parallel. So if we're doing the subtraction, that's the difference between them. And the difference here is always going to be minus 5. So this comes because these are parallel. Questions so far? Yep, this is as hard as it gets. Okay, let's do a multiplication. Oh, domain and range, thank you. Offer of XER. Okay, so how do we say negative 5 down? Confirm. Okay, multiplication. Let's talk about the functions first. So what is f of x? What kind of function? And what kind of function is the swoop? Square root. So that's just our square root of x graph. And what is g of x? A linear function. Okay, pick some x values. Negative 1. We like the right-hand side better than the left. Can't go past, right, because there's no graph there. Okay, so get your f of x, get your g of x values. I'll give you a couple of seconds to do that. Minus 1, offer for f of x.
0.
Offer for g of x. Confirm? Oh, clearly you can't see anything. Confirm. Okay. F of x at 0.
1.
And g of x
Negative 3.
at 1. Confirm. Okay.
Root 3 and negative 1.
3.
2 and 0.
Confirm. Okay, we're multiplying this time, so f times g of x. So 0 times negative 4. 1 times negative 3. Root 2 times negative 2. Negative 2 root 2. Root 3 times negative 1. And 2 times 0. And I want to highlight 2 of these. I want to highlight the negative 1 row. And I want to highlight the 3 row. Because somebody said it, so I wrote it down, and then you guys confirmed it. Anybody want to talk about where that comes from?
Because when it's a square root graph, you're going to go root 1, root 2, root 3, root 4, etc.
Little further explanation? Yes, Mr. Chatty Pants back there is clearly going to take it from you, Kelsey.
Sure, I can wrap this up.
Somebody else want to explain root 2? Since you guys confirmed it, we're like, oh yeah, root 2. I'm like, really? Okay. Anyone? Okay, would you like to put something different there? I'm not telling you. That's what you guys need to figure out. Okay, wouldn't 1 be root 1?
You're taking the x values and you're square rooting it, so it'd be easiest if you went -1, 0, 3.
Where are those numbers coming from?
Because that's, if we shift everything over, then it's 0, 1, 4, 16, square roots of those are whole numbers, so that's easy.
So what he's saying is these probably weren't great numbers to pick in the grand scheme, but we did pick them, so let's go with them. Well, don't forget the equation's written up here for you. Okay, and what do you know if we've shifted something 1 unit to the left? What have we done? It's just a horizontal translation of the square root graph. So if we hadn't have done that, okay, let's pretend it was a normal square root graph. At 1, it would have been square root of 1. But we've shifted it 1 to the left, so now it becomes square root of 2. So it just comes from the horizontal translation. If you were just to estimate these, I'm fine with that, because we're just doing it graphically. So if you looked and said, ooh, it's roughly 0.7, I'm fine with that. Does that answer your question? Go back to the 2 rows I highlighted. Why did I highlight these rows? So when multiplying, all x-intercepts will, so this was an x-intercept and this was an x-intercept. How do I know those were x-intercepts? Because the y value is 0, and what happens once we do the combination? They're still x-intercepts, so they will remain the same. So what this tells me is when you're multiplying, before I've done anything else, I know there's going to be a point at the 2 x-intercepts. I can mark those right away. I know those are going to be there when I'm multiplying, because anything multiplied by 0 is going to remain 0. So it's actually less points you need to calculate over here. Okay, so -1, 0 we've done. 0, -3. 1 and -2 root 2. What would you like to do with -2 root 2? Where would you like to plot -2 root 2? You have good estimation skills. Well, these probably wouldn't be calculated, but you have good estimation skills, so let's use them. Okay, root 2 has to be between what and what? Root 2 has to be between which 2 whole numbers? 1 and 2. How do we know it's between 1 and 2? This is painful. High five to Luke. Is it closer to 1 or closer to 2? Closer to 1. So let's give it an estimation. What would you like to call root 2? We know it's between 1 and 2. We just said it's closer to 1. 1.3, I heard the offer. Okay, now times that by 2. So would you like to estimate it at 2.6? You're confirming that? Because it makes sense to you, or just to get me off your back? Okay? What would you like to do with 2 and negative root 3? So again, use your estimation skills. Root 3 has to be between which two whole numbers? 1 and 2, is it closer to 1 or closer to 2? Okay, give me an estimation. .8 is the estimation. Confirm. Okay, how do we join these points? What the heck does this look like? What happens when you multiply a square root by a line? Is it going to be curved or is it going to be straight? Why is it going to be curved? Because the square root is curved. So if you have anything curved, the answer is going to be curved. What is it going to curve like? Okay. So keep in mind, mathematicians, not creative people. What do you think we call this graph? It is the fishhook graph. Questions so far? Let's do the same thing now, but let's do it algebraically. So to find the sum, difference, quotient, product of two functions algebraically, you must add, subtract, multiply, or divide the two functions, and then simplify the like terms. Okay, so we're going to do the exact same thing. We're just going to do it algebraically instead of graphically. Find h of x equals f minus g of x if f of x is this blah and g of x is blah, and we're going to subtract them. What kind of functions? Both parabolas. So what's going to happen when we subtract a parabola from a parabola? Is it going to stay a parabola? Is it going to change to a line? Is it going to become a cubic? What's going to happen? Why is it going to stay a parabola?
Because the highest degree is still 2.
And if we subtract, is that going to change the exponents? No. So we know we still need a parabola. Well, how do you subtract? You actually just subtract the functions. So I'm going to start with f of x, which was negative 3x squared, plus 5x minus 8. And then I'm going to subtract the other function, which is 4x squared plus 2x plus 6. Why do I need those brackets in the back? Subtracting is going to change all the signs, because we know this negative is going to apply to everything. Okay, so the negative 3x squared is going to stay the same. Plus 5x stays the same. Negative 8 stays the same. What's going to happen at the back? Okay, so minus 4x squared, minus 2x minus 6. Then we're just going to simplify. How many x squareds do I have? I heard 7. Negative. Oh, no, what? Who? Oh, negative 7. Okay, how many x's do we have? And the constants. That's it. That's done. That's what the question wants. Subtract the functions. There we go. Questions so far? Look at part B. Just steal my thunder. You know, just steal that from me. So we've actually done this in grade 10 when we started looking at functional notation and this f of x and g of x stuff. If they suddenly throw a number, this isn't saying multiply. This is saying take the x value and replace it for 2. So this is substitute all x's by 2. If they wanted you to take that function and multiply it by 2, what would that look like? So how would they tell you that? Where would that 2 be? In the front, the way we normally see it. So this is functional notation for substitute. That's what it means. So it's saying go back, get your hf minus g, take out the x, put in 2. No, it's substitution. Okay, BEDMAS says we do brackets first, nothing within the brackets. Then we go to exponent. So I'm going to do the 2 squared first. What do we do after exponent? Multiplication, because there's no division. So the first multiplication. And what do I do after multiplication and division? Adding and subtracting, so add it up. Offer of negative 36. So the point of this question is just for you to understand what this notation is asking you. It's just saying take x, replace for 2. How are we doing so far? This is grade 9 math. That's all we did. Okay, let's do our first division. So find h of x if f divided by g of x using blah, blah, blah. So just look how they tell you to do a division. Okay, so it looks like a little fraction, which we know just means division. Again, just watch the order. They want f on the top, and they want g on the bottom. Can we simplify? Okay, how would you like to simplify? Okay, what would you like to do with the bottom? Okay. Say that all one more time. I got lost at the beginning. 2x squared.
2x squared plus 1x minus 6x minus 3.
So you're just giving me step 1 of the factoring?
Yeah.
Okay, perfect. Bless you.
So then off with next, or, okay, so you want to go step by step.
Well, you started step by step, so let's finish step by step.
Okay. 2x plus 1. Negative 3. 2x plus 1. 2x plus 1 and x minus 3.
Whew. Can we cancel? No. So why can we not? Yeah, so this is a rational function. We would leave it like that. The only time we would cancel is if we're going to graph it, because what does this tell you about this canceling? It just tells you it's a whole. So you didn't actually need to factor to this point. We actually will need it for the next step, but that's where they want you to stop. So it's just the rational function x minus 3 over 2x squared minus 5x minus 3. The factoring wasn't a waste because the next one wants you to give the NPVs. What are NPVs? Right, and so that's the same as your asymptotes and your wholes. So we would have had to factor anyway to do that. So what can x not be? 3 and negative 1/2. If we were graphing it, then we would say specifically that 3 is the whole and the other is the vertical asymptote, but it's not what the question has asked. What does this mean, h of 0? Go into the h function, which we just found, and replace x for 0. What would you like it to be? Oh, that's beautiful. To a mathematician, we're like, yeah, what? What did we actually just calculate here? The y-intercept. How do we know it's the y-intercept? because we put 0 in for x. The point of this function, this unit is just to start looking at where do functions come from. So we did a whole unit on rational functions. Well, where do these come from? Well, it comes from in science when you're doing calculations and you have to divide two functions. That's typically where these come from because it's a division. Where do we use this? Well, that would take me weeks and weeks to explain. So one example in economics is we're often looking at revenue, right? Because economics is all about money, and we're looking how do companies make money. So how does a company make revenue? They sell stuff at a certain price. So to get the revenue function, you take the quantity sold times price. So there you're multiplying two functions. So in economics, we do this stuff all the time where you're multiplying to get revenue. You're going to use this in chemistry, in physics, biology, economics, any kind of science is where this stuff comes up. So it's just to start to look at what happens when you divide a line by a parabola, what happens when you multiply two parabolas, what happens when you do a square root and a parabola, et cetera, et cetera. Don't overthink this. This is as hard as it gets. That's all they want you to do is just get what the functions look like, maybe calculate a value, maybe state an NPV. That's it.